Hey guys, this is Gurjap. We are continuing our chapter of applications of derivatives, and today's first topic is slopes and tangents. So we know equation of a line passing through point x0, y0 with the slope m is given by y minus y0 is equal to m times x minus x0. So if we have a curve y is equal to fx, this is the curve y is equal to fx. So tangent is given by a line which is touching this curve at a point, and normal will be perpendicular to this curve. Okay, this is tangent, this is normal. Now tangent to this curve y is equal to fx is given by dx of y at x0 y0 is equal to f of x0, and the equation of tangent through this curve y is equal to fx at point x0 y0 is given by y minus y0 into is equal to f dash x0 into x minus x0. This is slope of the tangent, and this is equation of tangent at point x0 y0 passing through the curve y is equal to fx. Now we know if two lines are perpendicular to each other, their slopes are given by, if its slope is m1 and its slope is m2, then m2 will be equal to minus 1 upon m1. So now here normal is perpendicular to tangent, so slope of normal will be given by dx of y x0 y0 is equal to minus 1 upon m1, which is equal to m1 की वैल्यू क्या हमारे पास, slope of tangent is f dash x0. So we get minus 1 upon f dash x0. So its equation of normal will become y minus y0 is equal to minus 1 upon f dash x0 into x minus x0. Now let's look into some examples. Now in this example we have to find out the slope of the tangent to the curve. First curve is y is equal to 3x raised to power 4 minus 4x at x is equal to 4. A second curve is y is equal to x cube minus 3x plus 2 at x is equal to 3. So for the first curve we have y is equal to 3x raised to power 4 minus 4x. Now slope of the tangent to a curve y is equal to fx is given as dy dx at x0 y0. So we have to find its derivative. So we get dy dx is equal to dx of 3x raised to power 4 minus dx of 4x, which is equal to x4 का डेरिवेटिव क्या होगा, 4x raised to power 3. So 4x raised to power 3 multiplied by 3 we get 12x raised to power 3 minus 4x का डेरिवेटिव 4. Cool. Now we have to find its slope of the tangent, which is equal to dy by dx at x0 y0. y0 की वैल्यू हमारे पास है नहीं, but x0 की वैल्यू है at x is equal to 4. So we have to find its value. dy dx at x is equal to 4 will become 12 into 4 raised to power 3 minus 4, which is equal to, now 4 raised to power 3 multiplied by 12 will be equal to 768. So 768 minus 4, which is equal to 764. This is slope of the tangent for first curve. For the second curve we have y is equal to x cube minus 3x plus 2, and dy dx is equal to 3x dx of x cube minus dx of 3x plus dx of 2. Now derivative of constant is 0. Derivative of 3x will be equal to 3, and derivative of x cube will be equal to 3x raised to power 2. So we get derivative of y with respect to x is 3x square minus 3. Now we have to find its value at x is equal to 3. So dy dx at x0 y0 is equal to y0 दिया नहीं है मेरे को, so x0 की वैल्यू है x is equal to 3, which is equal to 3 into 3 square minus 3 3 square is equal to 9, 9 into 3, 27. So 27 minus 3 is equal to 24, and hence the result. Now in this case, we have to find slope to the normal of the curve x is equal to a cos cube theta and y is equal to a sin cube theta, where theta is equal to pi by 4. Clearly, this is a parametric function, so we have to find dy by dx is equal to, क्या होगी इसकी वैल्यू, dy by d theta, because theta is the parameter, divided by dx by d theta. So first point, dy by d theta will be equal to y हमारे पास a sin cube theta, so we get d theta, a constant बाहर आ गया, sin cube theta which is equal to a into sin cube theta क्या होगा, 3 sin square theta into derivative of sin theta जो कि होता है cos theta. Second, dx by d theta will be equal to a into d theta of cos cube theta which is equal to 3 times a cos square theta into derivative of cos theta which is equal to minus sin theta, so negative sin theta. So using these two values here, we get 3a sin square theta cos theta divided by minus 3a cos square theta into sin theta. 3 से 3 कैंसिल, a से a कैंसिल, cos से a cos की वैल्यू कैंसिल, sin से a sin की वैल्यू कैंसिल, we get negative of sin theta divided by cos theta which is equal to negative tangent theta. ये आ गई हमारे पास dy by d theta की वैल्यू. Now how do we find slope of normal? Slope of normal is equal to minus 1 upon slope of tangent. So tangent की slope कैसे निकालते हैं? dy by d theta, where theta is equal to theta naught. Now theta naught in this case is equal to pi by 4. So dy by d theta, where theta is equal to pi by 4, is equal to minus of tangent pi by 4. Tangent pi by 4 is equal to 1, so its value becomes minus 1. So slope of the normal will be equal to minus 1 divided by slope of tangent which is equal to minus 1, we get positive 1. So slope of normal to the curve x is equal to a cos theta, y is equal to a sin cube theta is equal to 1. In this example, we have to find equation of lines having slope 0 which are tangent to the curve 1 upon x square minus 2x plus 3. First step, tangent dy upon dx will be equal to second function, ये क्या है, कोशिएंट रूल लगेगा, so second function x square minus 2x plus 3 into derivative of first which is equal to 0 minus first function into derivative of second, that is dx of x square minus 2x plus 3 divided by square of second function x square minus 2x plus 3 whole square. Now this whole function is equal to 0. Here derivative of x square is equal to 2x minus derivative of 2x is equal to 2 and derivative of 3 is equal to 0. So this factor is 0, we get 0 minus 2x minus 2 divided by x square minus 2x plus 3 whole square which is equal to 2 into x minus 2 into x minus 1 divided by x square minus 2x plus 3 equal square. Now we are given that equation line have slope 0. So this should be equal to 0 implies minus 2 x minus 1 is equal to 0 implies x minus 1 is equal to 0. We get x is equal to 1. Now using this value of x in the original value, y is equal to 1 upon x square minus 2x plus 3, we get 1 upon 1 minus 2 into 1 plus 3 which is equal to 1 upon 1 minus 2 plus 3 which is equal to 1 upon 2. So the equation of lines passing through slope 0 which are tangent to the curve through the point 1 to the point x, y is equal to x की वैल्यू क्या हमारे पास 1, y की वैल्यू है 1/2, 1 by 2 is given by y is equal to 1/2 and hence the result. Now the next topic is approximation. Approximation means a value really close to the correct value but not the correct value. Suppose we have function y is equal to f of x and delta x be the increment, a small increment in the value of x. Increment means a little increase in the value of some value. So if delta x is increment to the value of x, then there will be a corresponding increment to the value of y denoted by delta y, which is equal to f of x plus delta x minus f of x. Now there's another formula, that is dy. How do you find dy? Dy is equal to f dash x into dx. We know f dash x implies dy by dx into dx. Now dx is approximately equal to delta x and dy is approximately equal to delta y. So replacing dx by delta x, we get dy is equal to dy by dx into delta x. We'll be using these two formulas to find approximate values of given in problems. Now we'll be using these two identities to find the approximate values of the given examples or given problems. For example, suppose we have to find value of under the root 36.6. Okay. Now suppose y is equal to under the root x, where x is equal to 36 and the small increment in the value of x, that is delta x, is equal to 0.6. So we need to find the value of delta y here. So delta y will be equal to, from this formula, f of x plus delta x minus f of x. Now f of x plus delta x will be 36 plus 0.6, that is under the root 36.6, minus f of x will be under the root 36. So 36, which is equal to under the root 36.6 minus 6. Now we have delta y is equal to under the root 36.6 minus 6. So I can also write it as under the root 36.6 is equal to 6 plus delta y. Okay, we need to find the approximate value of under the root 36.6. For that, we need to find the value of delta y. Now we know dy is equal to f dash x into dx. F dash x means dy by dx into dx, and dx is approximately equal to delta x. So we can write it as dy by dx into delta x, which is equal to, now f dash x, that is dy by dx, y के हमने assume किया था under the root x, so I can write it as dx of under the root x into delta x. Delta x की value हमारे पास 0.6, so it becomes equal to 1 upon 2 under the root x into 0.6, which is equal to 1 upon 2. X की value हमारे पास 36, so under the root 36 becomes 6 into 0.6. Now 0.6 divided by 6 into 2, that is 12, is equal to 0.05. So we can find out the approximate value of 36.6 is equal to 6 plus delta y. Delta y is equal to 0.05, so it is equal to 6 plus 0.05, which is equal to 6.05. This is how we use the method of approximation to find the values of such functions. Now the next example is we have to find approximate values of 81.5 raised to power 1 by 4. So here y is equal to x raised to power 1 by 4, where x is equal to 81 and the small increment in x is equal to 0.5. So delta y will be equal to, delta y is equal to f of x plus delta x, that is 81 plus 0.5 raised to power 1 by 4 minus 81 raised to power 1 by 4, which is equal to 81 plus 81.5 raised to power 1 by 4 minus this is 3 raised to power 4 raised to power 1 by 4, 4 so 4 cancel, so we get 81.5 raised to power 1 by 4 minus 3. So the value of 81.5 raised to power 1 by 4 can be found out by, we can write it as 81.5 raised to power 1 by 4 is equal to delta y plus 3. Okay, now we need to find the value of delta y. So we know dy is equal to dy by dx into dx, and the value of dx is equal to delta x. So we get d by dx of y is equal to x raised to power 1 by 4. So x raised to power 1 by 4 into dx that is delta x which is equal to now x raised to power 1 by 4 इसकी डिफरेंशिएशन क्या होगी 1/4 x raised to power 1 by 4 minus 1 which is equal to power 1 by 4 minus 1 into delta x की वैल्यू होगी हमारे पास 81 सॉरी 0.5 so 0.5 which is equal to 1 by 4 into x raised to power minus 3 by 4 into 0.5 which is equal to 1 by 4 into x raised to power 3 by 4. Now x की वैल्यू क्या है हमारे पास 81 and 81 can be written as 3 raised to power 4. So I can write it as 1 by 4 into 3 raised to power 4 raised to power 3 by 4. 4 से 4 cancel into 0.5 which is equal to 1/4 into 3 raised to power 3 into 0.5 which is equal to 1/108 into 0.5 which is equal to 0.0046. So we have the value of delta dy which is approximately equal to delta y. So I can write it as 81.5 raised to power 1 by 4 is equal to 0.0046 plus 3 which is equal to 3.0046 which is the approximate value of 81.5 raised to power 1 by 4. Now we have to find the approximate value of 0.009 raised to power 1 by 3. Here y is equal to x raised to power 1 by 3, x is equal to 0.008 and small increment in x delta x is equal to 0.001. So delta y will be given as f of x plus delta x that is 0.008 plus 0.001 raised to power 1 by 3 minus f of x that is 0.008 raised to power 1 by 3. Now 0.008 raised to power 1 by 3 can be written as 0.2 raised to power 3 raised to power 1 by 3. 3 is a 3 cancel. So we have delta y is equal to 0.009 raised to power 1 by 3 minus 0.2. So 0.009 raised to power 1 by 3 can be written as delta y plus 0.2. Now we have to find the value of delta y. So we know dy is equal to dy by dx into dx. Now dx is approximately equal to delta x. So replacing dx by delta x we get dx of y is equal to x raised to power 1 by 3 into delta x क्या हमारे पास 0.001 which is equal to ddx of 1 by 3 will be 1 by 3 x raised to power minus 2 by 3 into 0.001 which is equal to 1 by 3 into x raised to power 2 by 3 into 0.001. Now we have x raised to power 2 by 3, x की वैल्यू हमारे पास 0.008 so I can write it as 1/3 0.2 raised to power 3 raised to power 2 by 3, 3 से 3 cancel into 0.001 which is equal to 1/3 into 0.04 into 0.001 which is equal to 0.008. Now we know dy is approximately equal to delta y. So using the value of delta y in this result we can find the approximate value of 0.009 raised to power 1 by 3 is equal to 0.2 plus 0.008 which is equal to 0.208 and hence the result. Now the next topic is maxima and minima. Suppose f is a real valued function in an interval I and f is said to have a maximum value if f of c is greater than f of x where c is the point of maximum value and this c lies in the interval. And we say that it has a minimum value if f of c is less than f of x where c is called the point of minimum value. This is the basic definition of maxima and minima, but the approach to the problems regarding maxima and minima is a bit different. So suppose that you have a function f of x, you have to find its maximum or minimum value. What you do, you have to somehow find a number for which आपको कोई भी एक number, कोई constant number निकालना है, suppose a. And you have, if you prove that this value of f of x is less than this number a, then we say f of x has a maximum value. And if you can prove that f of x is greater than some constant a, then we say that f of x have a minimum value. This is the basic approach to the problems regarding maxima and minima. For example, suppose we have a function f of x is equal to x minus 1 square plus 3. Okay, we have to find its maximum or minimum value. So firstly we know किसी भी नंबर का स्क्वायर क्या होता है हमेशा पॉजिटिव. So x minus 1 square is greater than equal to 0. Second point, if we add 3 on both sides, we get x minus 1 square plus 3 is greater than equal to 3. Now this is whole as a function f of x. So f of x is greater than equal to 3. Now if a function is greater than some constant number, greater than equal to some constant number, then we say it has a minimum value. Where would it have a minimum value? For that we have to put this value is equal to 0. So x minus 1 is equal to 0 implies x is equal to 1. So at x is equal to 1, this function will have the minimum value, and then minimum value will be equal to f of 1 is equal to 1 minus 1 square plus 3 which is equal to 3. तो फाइनल रिजल्ट हमारे पास मिनिमम वैल्यू क्या आई 3. वो आप यहाँ से भी डिड्यूस कर सकते हो, शॉर्टकट यहाँ से भी देख सकते हो कि अगर f of x की वैल्यू किसी नंबर से बड़ी आ रही है तो इट हैज़ अ मिनिमम वैल्यू एंड दैट नंबर विल बी कॉल्ड द मिनिमम वैल्यू ऑफ दिस फंक्शन. बट डू नॉट यूज, आई वुड एडवाइज, डू नॉट यूज this method to find result in your exams or in problems regarding in your school or anywhere. You should use this long method. पहले आप देखो मिनिमम वैल्यू है, मैक्सिमम वैल्यू है, then you find the value of x at which this function will attain its minimum or maximum value, then you find its minimum value. Now let's look at another example. Say we have f of x is equal to minus of x minus 1 square plus 10. So we know x minus 1 square is always positive, but negative of this whole square will always be less than 0. So this is less than equal to 0. Second point, if we add 10 on both sides, we get minus x minus 1 square plus 10 is less than equal to 10. Since this f of x is less than some constant number, so we say it attains maximum value. Now we know its maximum value is equal to 10, but let's find it properly. So to find its maximum value, we have to put x minus 1 should be equal to 0, implies x is equal to 1. So this function will attain its maximum value at x is equal to 1, and that maximum value will be equal to f of 1. So f of 1 is equal to minus of 1 minus 1 square plus 10, which is equal to minus 0 or 0 plus 10, which is equal to 10. So the maximum value of this function is 10, and we attain its value at x is equal to 1. Now the next topic is second derivative test. We use this test to find the point of local minima and local maxima, and also to find the maximum and minimum value of a function. You can pause the video right now for a definition. Now I will explain how to use this method properly to solve an example. So suppose we are given a function f of x. First point is to find the first derivative, that is f dash x. Then we find second derivative f double dash x. Now we'll put f dash x is equal to 0, and we'll get some value x is equal to a. Using this value in f double dash x, we get f double dash a. अब इसकी वैल्यू या तो लेस देन 0 होगी या तो ग्रेटर देन 0 होगी. In case the value of f double dash a is less than 0, then we say this is point of local maxima, and the maximum value is attained in this case at f of a. And if f double dash a is greater than 0, then we say this is point of local minima, and the minimum value in this case will be attained at f of a. Okay, this is how you use first second derivative test to find local minima, local maxima, maximum and minimum values. For example, suppose we have f of x is equal to x cube minus 3x. We have to find its maximum minimum value or local maxima, local minima. First step, f dash x, which is equal to 3x minus 3. We put this equal to 0. So 3x square, minus 3 is equal to 0 implies x square is equal to 1, or x is equal to plus minus 1. So we have two values of x is equal to 1 which is greater than 0. So this is point of local minima, and the minimum value will be given by f of a. A means f of 1. So f of 1 in this case is 1 cube minus 3 into 1. So 1 minus 3 which is equal to minus 2. So the minimum value is minus 2, and x is equal to minus 1 is less than 0. So this is point of local maxima, and the maximum value is given as f at a. So f at a क्या हमारे पास -1, so -1 cube minus 3 into -1 which is equal to -1 plus 3 which is equal to 2. So the minimum value is -2 and maximum value is 2. Now the next function is f of x is equal to sin x plus cos x, and we have to find its maximum or minimum value in the interval x from 0 to pi by 2. So first step, f dash x is equal to dx of sin x plus derivative of cos x. Sin x का derivative cos x, cos का minus sin, so we get cos x minus sin x. Next point, we have to put f dash x is equal to 0. So this is equal to 0, which it will be equal to 0 when sin x is equal to cos x, or tangent x sin x upon cos x is equal to 1 implies tangent x is equal to 1. Now tangent x is equal to 1 at pi by 4. So we have x is equal to pi by 4, which lies in the interval 0 to pi by 2. So using this value in f double dash x in this case will be equal to minus sin x minus cos x, which is equal to minus of sin x plus cos x at pi by 4. So minus sin pi by 4 plus cos pi by 4 is equal to, now sin at 45 degrees is equal to 1 upon under root 2, cos at 45 degrees is equal to 1 upon under root 2. So we have negative of 1 by under root 2 plus 1 by root 2, which is equal to negative of 1, LCM of 1 upon under root 2 plus 1 upon under root 2 is equal to under root 2 into under root 2 implies 2 upon numerator में आ जाएगा under root 2 plus under root 2, which is equal to negative of 2 root 2 divided by 2, 2 से 2 cancel, which is equal to negative under root 2, which is less than 0. So f double dash x is less than 0. x क्या था हमारे पास pi by 4. So x is equal to pi by 4 is the point of local maxima, and maximum value of this function will be given at f of pi by 4, which is equal to sin pi by 4 plus cos pi by 4. Now sin pi by 4, cos by 4, pi by 4 is equal to 1 upon root 2, which is equal to 1 upon root 2 plus 1 upon root 2, which is equal to 2 root 2 upon 2, which is equal to root 2. So root 2 is the maximum value of this function. Now let's see how to find absolute maximum and absolute minimum values. Suppose we have a function f of x where x belongs to closed interval ab. Next step, we'll find f dash x. So first derivative of f dash x, we put it equal to 0. In return, we'll get some critical values, that is x is equal to c. एक वैल्यू भी हो सकती है, दो भी हो सकती है, तीन भी हो सकती है. So to explain, I'll use two values. Say we have two values of x is equal to c and d. Now we'll find the value of this function at these critical points and at the end points of this interval. Means we'll find the value of f of a end points पे, f of a, f of b, and then at the critical points f of c, f of d. हमने इस फंक्शन की वैल्यू निकाली एट एंड पॉइंट्स ऑफ द इंटरवल, एट क्रिटिकल पॉइंट्स. देन विल सी कि किस केस में सबसे ज़्यादा वैल्यू आ रही है, हम उसको बोलेंगे एब्सोल्यूट मैक्सिमम वैल्यू, और जिस केस में सबसे कम वैल्यू आ रही है हम उसको बोलेंगे एब्सोल्यूट मिनिमम वैल्यूज. नाउ फॉर एग्जांपल, सपोज वी हैव एफ ऑफ एक्स इज इक्वल टू 2x क्यूब माइनस 15x स्क्वायर प्लस 36x प्लस 1 वेयर x बिलोंग्स टू द क्लोज इंटरवल 1, 5. सो फर्स्ट स्टेप f dash x which is equal to 3 to the 6x square minus 30x plus 36. अब तीनों में 6 कॉमन है, वी हैव टू कंपेयर इट टू 0. सो नेक्स्ट स्टेप, हमें निकालनी है x की वैल्यू, दैट इज क्रिटिकल पॉइंट्स. सो तीनों में 6 कॉमन है, कॉमन ले लो 6 इंटू एक्स स्क्वायर माइनस 5x प्लस 6 विच इज इक्वल टू 0. सो वी गेट 6 इंटू एक्स स्क्वायर. अब कौन सी ऐसी वैल्यू है जिसको ऐड करके या सब्ट्रैक्ट करें वी गेट 5 माइनस 5, और जिसको मल्टीप्लाई करके वी गेट 6. वी हैव -3 एंड -2. सो -3x minus 2x plus 6 is equal to 0 implies 6x minus 3 minus 2x minus 3 is equal to 0 implies 6 into x minus 2 into x minus 3 is equal to 0. तुम्हारे पास x की वैल्यू, x की दो वैल्यूज आ रही है, x is equal to 2 and x is equal to 3 and x is equal to 3. तुम्हारे पास 4 पॉइंट्स हैं जिस पे हमें इस फंक्शन की वैल्यू निकालनी है, 1, 5, 2 एंड 3. सो एट x इज इक्वल टू 1 वी हैव f of 1 इज इक्वल टू 2 इंटू 1 क्यूब 2 माइनस 15 प्लस 36 प्लस 1 विच इज इक्वल टू 2 प्लस 1 3 प्लस 36 39 माइनस 15 विच इज इक्वल टू 24. ये आ गई हमारे पास फर्स्ट इंटरवल की एंड पॉइंट की, दैट इज 1. अब निकालेंगे हम f ऑफ b, दैट इज 5 पे. नाउ f ऑफ 2 विल बी इक्वल टू 2 इंटू 2 क्यूब माइनस 15 इंटू 2 स्क्वायर प्लस 36 इंटू 2 प्लस 1 विच इज इक्वल टू 2 इंटू 8 माइनस 15 इंटू 4 प्लस 36 इंटू 2 प्लस 1 विच विल बी इक्वल टू, इसको सॉल्व करके हमारे पास आंसर आ जाएगा 29. सो f of 2 is equal to 29. Next is f of 3 and then f of 5. f of 3 will be equal to 2 into 3 cube minus 15 into 3 square plus 36 into 3 plus 1 which will be equal to 28, and f of 5 will be equal to 2 into 5 cube which will be equal to 125 minus 15 into 25, that is 5 square plus 36 into 5 plus 1 which will be equal to 56. Now f of 5 is equal to 56 is the maximum value out of all of these 4 values, and f of 1 is the minimum value, that is 24. So the absolute maximum value, we'll write that the absolute maximum value of this function f of x in the interval 1 to 5 is equal to 56, and it is attained at x is equal to 5, and the absolute minimum value of f of x in the interval 1 to 5 is equal to 24, and it is attained at x is equal to 2, and hence the result. So guys, this was it for today. If you have any problems regarding this chapter of application of derivatives, you can leave them down in the comment sections. We'll start a new chapter from the next video. Till then, keep practicing.